Hey, so if you've ever used a chat AI, you know that feeling, right? That almost magical conversation. But have you ever really stopped and wondered what is actually going on behind the screen?
I mean, you type in a question, anything from write me a poem to explain quantum physics, and boom, seconds later, this perfectly coherent answer just appears. It just starts typing itself out. So how does that really happen? What's going on in that little pause between you hitting enter and the answer showing up?
All right, today we're going to pull back the curtain. Think of this as a guided tour of the AI engine room. Our goal? To replace that "it's just magic" feeling with a real solid understanding of the incredible engineering that makes all this possible. So, yeah, let's dive right in. Okay, so the very first hurdle is pretty fundamental. Computers, they don't get words. They only speak in numbers. So the big question is, how do you translate our language into something they can actually process? Well, it's basically a three-step process. First up, your sentence gets chopped up into these little pieces called tokens. Think of them as subwords. Then each of those tokens gets mapped to a special string of numbers called an embedding. Now you can picture an embedding as a coordinate, like a point on a huge, multi-dimensional map of meaning. And finally, the model also encodes the position of each token. And that's super important, right? Because dog bites man means something totally different from man bites dog.
So now we've got our text translated into a big grid of numbers. The next step is to actually process it. And this is where the real game changer comes in. The breakthrough architecture that powers pretty much all modern AI, the transformer.
And the transformer's secret sauce? It's this amazing thing called self-attention. It's basically a mechanism that lets the model look at an entire sentence all at once, and for each word, it weighs how important all the other words are to it. This is how it gets context. It's how it knows who he is referring to 3 sentences back.
And this self-attention mechanism is what turns the model into a kind of universal pattern matcher. See, it doesn't just have one attention mechanism, it has lots of them, called attention heads, all working at the same time. You can think of each one as a specialist. One might be looking for grammatical connections, another might be tracking the flow of an argument, and a third could be focused on the structure of computer code. It's this crazy versatility that lets it understand so many different types of information.
So we've got this incredibly powerful engine, right? The transformer. But every engine needs fuel. And for an AI model, that fuel is, well, it's a staggering amount of human knowledge. We're talking text and data from basically the entire internet and more.
Now, during its first phase of training, what we call pre-training, the model's goal is actually shockingly simple. Just predict the next token. That's it. It's fed billions and billions of pages from books, articles, and websites, and its only job is to guess what comes next. But by doing this over and over trillions of times, something incredible happens. It starts to learn the underlying patterns of language, facts about the world, and even different styles of reasoning.
And this is really important because it busts a super common myth. The model is not a giant search engine or a database that's just memorized its training data. It's not just copy-pasting. Instead, it's learning to generalize the patterns and concepts from that data. And believe me, that distinction is absolutely key to getting how these things work.
Okay, so at this stage, what we have is a raw, incredibly powerful model. It knows a ton, but it's not an assistant yet, not even close. It's more like a wild, unfocused text completion engine. It knows how to write, but it doesn't know what it should write. It needs to be aligned. And just look at the difference here. On one side, you've got the raw, pre-trained model. It's just a pattern completer. It can be unhelpful, unfocused, even amoral. But on the other side, you have the tuned assistant. This version has been specifically shaped by human feedback to follow instructions and to be helpful, harmless, and honest. This transformation, it's everything. So how does that tuning actually happen? It's a really cool 3-step process. First, there's what's called supervised fine-tuning, or SFT. This is where the model learns by seeing thousands of high-quality examples of good conversations. Step 2 is preference modeling. Here, human reviewers are shown multiple AI answers to the same prompt, and they rank them from best to worst. This teaches the model what we mean by better. And finally, all that data is used to optimize the model at a massive scale, using techniques like RLHF, that's reinforcement learning from human feedback. This is what really shapes its personality and installs those safety guardrails. All right, so the model is built, it's been trained on the world's knowledge, and it's been aligned to be a helpful assistant. Now, let's put all the pieces together and see how it actually handles a real, live conversation with you.
So here's the crazy secret to how these AIs remember your conversation. They don't. There's no actual memory. Instead, with every single thing you type, the entire conversation history is bundled up and set back to the model as one giant prompt. This whole package includes any hidden system instructions, every one of your messages, all of the AI's past replies, and even any tools it might have used along the way.
And that last part about tools is super important. You have to remember, the model's internal knowledge is frozen at the time it was trained. It doesn't know what happened yesterday. So to give you fresh information or to perform actions, it needs to be given tools. It can be programmed to decide, hey, for this question, I need to search the web, or I need to run some code. It then gets the result from that tool and weaves it into the answer it gives you.
But of course, the system is far from perfect. It's so important to understand its built-in limitations. For one, it can hallucinate, which is a fancy way of saying it can confidently make things up. It can also inherit biases from its training data. Without its tools, it can trip up on pretty basic math and logic. And if a chat gets really long, it can start to lose track of the context. The big takeaway here, always verify any critical information you get from it. So as we wrap this up, let's circle back to where we started. A chat assistant isn't some magic oracle, but it's not a simple computer script either. It's a complex, layered system. You've got this powerful probability engine at the core, which has been carefully fine-tuned by human preferences, then connected to a whole toolbox of capabilities, and the entire thing is wrapped in safety guardrails.
And once you understand all those layers, you have a much better mental model for how to use this technology well. It stops being magic and starts being a tool. And that leaves us with the biggest question of all. Now that we know how the engine works, what should we build with it? And just as important, how do we make sure we do it responsibly?